conventions today are the same as day one. Okay. So no change in the conditions. But we do have a null hypothesis and an alternative hypothesis. The null hypothesis will always be the proportion of one equals the proportion of the other. That the proportions are equal. Always this. And if the null is true, then P1 minus P2 would always equal 0. The alternative is simply going to be something like P1 is less than, greater than, or not equal to one of those three, P2. And whatever that is, if you're not sure, it's not equal to. If you think you have some idea one way or the other, you go with one of those others. Something that I haven't mentioned before, and that probably is something maybe that I should have earlier, but the null and the alternative hypothesis come into play before you do the study. Hey, I'm curious about this. So the null and alternative are never set after the data is collected. So don't look to the information for the null or the alternative hypothesis when you're writing it. Look for the statement about about what the original question was. So we're almost done with notes. Z equals the difference in p hat 1 minus p hat 2. Put those guys in parentheses. Minus 0. How do we get z? We always get z by standardizing, right? This is a standardizing formula with two proportions over the square root of the standard deviation, or the standard error in this case, p hat 1 times 1 minus p hat 1. This is like the bit that was in yesterday's formula, or the other days, plus p hat 2 times 1 minus p hat 2 all over n sub 2. Now, yesterday's class questioned me on the 0. Where did the 0 come from? Anybody have any idea where the 0 comes from here? What's the 0? The 0 is the difference that you get when you subtract, or you should get when you subtract the two proportions, the population proportions up here. So this and this are related. Because remember, in the standardizing formula for just a proportion, you have p hat minus p. Well, this is now the difference in p hats, and this is what we will always expect to get when we get the difference in the two proportions. So this is your p hat, this is your p. Yes? Now, that said, I don't think you're going to need this formula. I just don't think it's going to come up all that much. We're going to use another formula, but let's add a note here. P1 minus P2 is what this guy is, and it's when the null is true, it always gives 0. And the null hypothesis is there because you expect it to be true. This is an assumption that the null hypothesis is true and that we would get that 0, and that's totally acceptable. We want to test to see if that's not true. That's what we're doing. So we're testing, is it not true versus is it true, basically here. Okay, and so that leads us to the shortcut, the 2-prop z-test. That's the guy I want you to use, because a lot less mistakes will be made. And then, of course, you have your conclusion. Let's see. I didn't write conclusions yesterday, but I think I probably should. So, conclusion, if you reject the null, we have significant evidence. To reject the null, and conclude the proportions are different is basically what it comes down to. You'll definitely need to get some context in there. Different could be greater than, less than. Different is not equal to, something like that. Okay, the two proportions are not equal. Or we fail to reject the null. And conclude the proportions are not significantly different. Of course, type 1 and type 2 errors still come into play on these. We have significant evidence to reject the null and conclude the proportions are different, or we fail to reject the null and conclude that the proportions are not significantly different. Again, context needs to be put into there somehow. Depends on the problem. We'll look at a problem next where we'll have some context. Everybody good? All right. All right. So let's take a look at problem number 21. It's on page 641. Bag lunch. And this problem might be something that I think you guys could all probably relate to. It says, Phoebe has a hunch that older students at her very large high school are more likely to bring a bag lunch than younger students because they have grown tired of cafeteria food. She takes a simple random sample of 80 sophomores and finds 52 of them bring a bag lunch, and a simple random sample of 104 seniors reveals 78 of them bring bag lunch. So we've got sophomores, 52 out of 80. So this is my x sub 1 and my n sub 1. And if I just get the p hat value for that, that's going to be 0.65. And the seniors is 78 out of 104. So that's my x sub 2 and n sub 2. That's about 75. Maybe it is 75. Seems to me like I rounded one of those numbers and I forget which one I rounded. So about 10% more of the sample as a proportion of seniors bring their lunch as opposed to eating the cafeteria food. All right, so conditions. SRS? That was stated. Yeah, it's given for both proportions. Is it independent? Well, do you think that 10% of all sophomores is greater than 80? Now think about that for a second. That means that you have to have over 800 sophomores. It did say in the problem that it was a very large high school. I would call this a monstrosity. Okay? Mountain View, yeah, maybe, I'm not even sure Mountain View and Rocky would be this big. But there are schools out there, they're pretty rare, but there are schools out there that are like 4,000, you know. Like, what's that? Texas, I'm thinking, I don't even know, inner city LA, New York, something like that. So is 10% of all seniors greater than 104? That means there's over 1,040 seniors. This is a huge high school because usually there's fewer seniors than there are the other classes. Usually.
Yeah, there's a smaller
It happens at times, sure, it does. But a lot of times the senior class is smaller simply because of attrition. People have gone on to study online, or they've gone to other alternative school settings, or maybe they've just flat out said, I'm done. Okay. I'm going to say it's reasonable to assume, RTA, don't use RTA at the stats test, reasonable to assume large or a very large high school meets this condition. Okay. So I think we're good with that. Is it normal? Well, is 80 times 0.65 greater than or equal to 10? Yes, for sure that's true. 80 times 1 minus 0.65, which would be 0.35, greater than or equal to 10? Yes, we're good for the sophomores. We've got to check it for the seniors. Yeah, we're good there. 75% of 104, definitely bigger than 10. 104 times 25%, also greater than or equal to 10. So we've met our conditions. So we are normal. Conditions met. Okay. And we need our null and alternative. What's our null going to be? It's always not minus. Equals. There you go. P1, the proportion of sophomores that eat lunch in the cafeteria is equal to the proportion of seniors that eat lunch in the cafeteria. Okay. And our alternative. I'm not sure. Did I miss that? Let's see. What did they say?
Less seniors eat in the cafeteria.
That's exactly right. So that's what she's saying. So that's going to be P1. The sophomores is less. Yeah, more seniors bring their lunch. So more seniors bring their lunch. Okay. So soph, senior, soph, senior, just for some clarity there. So I'm going to go to the two-prop z-test. Go shopping in the calculator. Find my calculator. I need to go shopping for a calculator. So stat, tests. We want the two-prop z-test. It's number 6. Should be really simple. We have to put in our numbers for sophomores, which is going to be 52 and 80. And our numbers for the seniors, 78 and 104. And choose the right test. Let's see, that's going to be this guy right here. I'm going to write that down. Even though we've kind of already got that written down elsewhere, I'm going to throw that out there. So let's calculate that guy. So for P1 is less than P2. I'm not going to rewrite that. That's already down there. We've got Z negative 1.48 P 0.0 about 0.07, huh? P1, P2, or P hat 1. I haven't written that down yet, at least not recently. P hat. N1 and N2 I have. Alright, now one other thing. Oh, they did give us alphas 0.05. So, if alpha is 0.05, I'm comparing my p-value to alpha. Do I reject or fail to reject? Yeah.
Do we have to write out all of the variables that we put in like on the AP test or something?
I would. Yeah. I don't know, it seems ridiculous that you would repeat some of the stuff that we've already written above. That seems unneeded, but unless you're concerned about time, I think I'd throw it back in there. Yeah. That way you're saying, hey, this is what I put in for that. That way if you make a mistake, then they can double check it, which they may do. So, getting back to outside of the tail. Is there any concern about a type 2 error? Yeah, it's too far away to be concerned about that. So we fail to reject. And conclude there is not significant difference, or let's see, what did I write last time? I think I can improve on this. There is not significantly more seniors let's see, how about we say not a significantly larger proportion of seniors that bring their lunch. I like that. That'll work. Wait a minute. I thought I just turned you off.